So what exactly is soil? Simply put, it's the unconsolidated mineral and organic matter left behind as rocks weather over time. It contains water, air, humus, and living organisms, all working together to support plant life. But if you remove those living organisms, well, then you just have dirt which is lifeless, inactive, and kind of useless for plant growth. Soil does a lot more than just help plants grow. It serves as a medium for vegetation growth. It helps modify the atmosphere by absorbing and releasing gases. It provides a habitat for countless organisms, from bacteria to burrowing mammals. It stores, filters, and purifies water, which is crucial for ecosystems. It even recycles nutrients and preserves artifacts. Yep, soil can trap and protect ancient remains, like carbonized plants and even fossils. Soil formation isn't instant. It takes thousands of years. The process starts with regolith, the broken-down rock material that eventually becomes soil. Here are the key processes that make soil what it is. Weathering, rocks break down due to temperature changes, water, and biological activity. Leaching, nutrients are pulled down into lower layers by percolating water. Capillary action, the opposite of leaching. Water moves upwards, bringing nutrients to higher layers, common in dry areas. Organic decay, dead plants and animals break down into humus, enriching the soil. Not all soils are the same, and that's because several factors influence how soil develops. Parent rocks determines how porous, acidic, or nutrient-rich the soil is. Topography, elevation, slope, and aspect affect moisture and erosion. Flora and fauna, the types of plants and animals in an area impact organic decay. Time, it takes 3,000 to 12,000 years for soil to develop enough to support agriculture. Climate, temperature, and rainfall affect weathering and vegetation type. Soil isn't just one uniform mass, it has layers called horizons. Horizon, the topmost layer full of decomposing leaves and organic matter. A horizon is dark, rich in humus, and where most plant roots grow. Horizon, subsoil, a dense layer where leached minerals accumulate. Horizon, parent material, weathered rock breaking down into soil. Horizon, bedrock, solid rock foundation of the soil. Now, let's talk soil types. Different conditions produce different soils, each with unique characteristics. Laterites, the leached tropical soils. Lateritic soils are predominantly found in the humid tropical regions of South America, Africa, and Southeast Asia, where intense heat and heavy rainfall accelerate soil-forming processes. These soils are primarily the result of chemical weathering, where prolonged exposure to moisture breaks down rocks, dissolving and washing away soluble minerals. The combination of high temperatures and rapid organic decay causes plant matter to decompose quickly, leaving little time for humus to accumulate. Laterites are easily recognizable by their distinct reddish-brown color, which is due to high concentrations of iron and aluminum oxides, the only minerals that withstand extreme leaching. Unfortunately, this process strips the soil of essential nutrients, making it highly infertile for most crops. However, with proper irrigation and fertilizers, lateritic soils can support commercial crops like pineapples and sugarcane. Additionally, the hardpan layer within these soils is often used as a building material, as it solidifies when exposed to air. Podzols, the acidic forest soils. Podzol soils are characteristic of coniferous forests in North America, Russia, and parts of Europe, where they form under cold and moist conditions. Due to the low temperatures, decomposition of organic material occurs very slowly, resulting in minimal humus accumulation. The dominant vegetation, pine and spruce trees, produces acidic leaf litter, which further lowers soil pH. These soils undergo severe leaching, where rainwater drains through the upper layers, removing essential minerals and leaving behind a gray, red, or yellowish subsoil. The constant movement of nutrients downward creates a distinct horizon of alluviation, where leached minerals accumulate. Podzols are highly acidic and nutrient-poor, making them unsuitable for most agricultural crops. However, in regions where the soil has a slightly lower acidity and a thicker humus layer, crops like corn and soybeans can still be grown. Chernozems, the fertile grassland soils. Often referred to as black earth soils, Chernozems are among the most fertile soils on Earth. They are found in the temperate grasslands of Canada, the USA, and Europe, where moderate rainfall and seasonal temperature variations support the gradual buildup of organic material. Unlike tropical soils, where organic matter decomposes too quickly, grassland vegetation sheds plant material at a steady rate, forming a deep layer of rich, dark humus. These soils also contain a high concentration of calcium carbonate, which helps retain nutrients and moisture, making them extremely fertile. As a result, chernozems are ideal for growing grain crops such as wheat, oats, barley, rye, and maize. Their fine-grained clay structure further enhances water retention, ensuring steady crop growth even in semi-arid conditions. Rendzinas, the young mountain soils. Rendzina soils are commonly found in Europe and other mountainous regions, particularly in areas with karst landscapes, regions dominated by limestone bedrock. These soils develop on steep slopes, where erosion frequently exposes new layers of parent rock, preventing the formation of deep soil layers. Unlike highly leached soils, rendzinas retain much of their original calcium content, resulting in a dark brown, calcareous composition with a neutral to slightly alkaline pH. Their high humus content makes them relatively fertile, although their thin and shallow nature limits their ability to support deep-rooted crops. Due to their rocky terrain and limited soil depth, rendzinas are mostly used for grazing livestock and forestry rather than large-scale agriculture. Latosols, the poorly draining tropical soils. Latosols are widespread in savanna and equatorial regions, where they form under high temperatures and heavy rainfall. These conditions lead to rapid leaching, where rainwater washes away nutrients faster than they can be replenished. Additionally, organic matter decomposes quickly due to the warmth and humidity, leaving little behind to enrich the soil. A key feature of latosols is their reddish-yellow color, a result of accumulated iron, aluminum, and silica. Unlike podzols, these soils lack a distinct alluviation zone, as nutrients are continuously drained downward without forming concentrated deposits. The result is a nutrient-poor soil that supports only bushes and grasses rather than dense vegetation. While latosols are largely unsuitable for traditional farming, they are commonly used for building materials and livestock grazing. Moving on to local soils found here in the Bahamas, which are relatively young compared to those on larger continents. Due to the island's limestone base and tropical climate, these soils tend to be thin, stony, and patchy, with limited fertility. The three primary types of Bahamian soils include black soil, organic soil, found in forested areas, particularly in the north and central Bahamas. This soil type is rich in rotted vegetation and humus, making it one of the more fertile options on the islands. Red soil, residual or pineapple soil, less common but more fertile than other Bahamian soils, this type contains high clay content. The characteristic red color comes from fine dust deposits blown over from the Sahara Desert. Sedimentary soil, found in areas with sand dunes, this soil is a mixture of sand and humus, giving it a distinctive salt and pepper appearance. It is not particularly fertile but can support certain types of coastal vegetation. Despite their limitations, Bahamian soils have supported agriculture in small-scale farming, fruit cultivation, and forestry. However, given their patchy distribution and low nutrient content, soil conservation is essential to prevent degradation and maximize agricultural potential. Soil erosion happens when the top layer of soil, the part rich in nutrients, gets stripped away by forces like wind, water, or human activity. Some causes are natural, while others are due to how we use the land. Only 11% of Earth's land is ideal for farming, so preventing erosion is crucial. Overcultivation, planting crops over and over without giving the soil a break. Imagine working nonstop without rest. Eventually, you'd burn out, and that's what happens to soil too. Overgrazing. Too many animals feeding in one place eat all the grass, leaving the soil exposed and easy to wash or blow away. Monoculture. Growing just one type of crop repeatedly depletes specific nutrients, making the soil weaker and more vulnerable. Deforestation. Trees are like nature's anchors for soil. When we cut them down, we remove that stability, and the land starts to wash or blow away. Mining and urbanization. Digging up land for minerals or expanding cities disrupts natural landscapes, making soil more likely to erode. Natural causes include forest fires, burn away vegetation that holds soil in place. Volcanic eruptions cover the land in ash, making it unstable. Landslides, sudden shifts of land due to heavy rains or earthquakes. Floods, rapid water flow washes away large amounts of soil. Soil erosion doesn't just happen in one way. It comes in different forms depending on how nature or people affect the land. Splash erosion. Imagine raindrops acting like tiny bombs, hitting the ground and loosening soil bit by bit. Sheet erosion. Instead of dramatic landslides, this happens slowly as a thin layer of soil gets washed away by flowing water. Rill erosion. Small channels form as water starts cutting paths into the land. Think of it like tiny streams forming in the soil. Gully erosion. If rill erosion keeps going unchecked, those small channels grow into deep trenches, making land nearly impossible to farm. Wind erosion. In dry, open areas, wind can pick up loose soil and carry it away, sometimes forming dust storms. Now that we know what causes soil erosion, how do we stop it? Here are some smart ways to protect and restore soil. Shifting cultivation. Farmers move their fields around to give the soil time to recover. Think of it like letting land take a nap before being used again. Crop rotation. Instead of planting the same thing every season, farmers switch it up to replenish different nutrients in the soil. Terracing. On steep hills, farmers carve out steps to slow down water flow and stop soil from washing away. Strip cultivation. Alternating strips of planted and unplanted land helps hold soil in place and prevent erosion. Contour farming. Instead of plowing straight downhill, which speeds up erosion, farmers plow along the natural slope of the land to slow water runoff. Shelter belts. Planting rows of trees acts as a wind barrier, protecting soil from being blown away. Natural fertilizers. Using compost or manure instead of harsh chemicals helps restore soil health. Tree crops. Deep-rooted plants like fruit trees help keep soil anchored and prevent erosion. By using these methods, we can keep our soil healthy, fertile, and productive for future generations. After all, without good soil, there's no good food. If you found this video helpful, make sure to like, subscribe, and check out our other videos to learn more.